what is the reason that we have to improve on existing feature selection? Now, feature selection has been around for some time. It's not our invention. Why are we writing a paper on it? The papers that we have written on it is because of our observation that common feature selection method actually generate different rankings when you run it with different random seed. For example, if you permute, the random seed is needed for permutation of the rows, as you remember, randomizing the row. But every time you permute it differently, oftentimes it would give you a different feature importance ranking. Now, and that is a very disappointing result to us when we first applied feature selection. We were hoping that every time we rank it, we'll get the same important feature that determines whether our strategy will be profitable. Is it going to be volatility? We are hoping that every time it will say, oh, volatility is what determines your strategy in profitability. Or the commodity futures returns is what determines it. But unfortunately, every time we run it on different computer using different random seed, we get different rankings. That is a severe problem because it removes any confidence in this ranking, and it removes any intuition or interpretability of this feature importance ranking, right? So, for example, let's say we are using a bunch of technical indicators to predict the oil ETF USO's return. Let's see what happens when we do that, okay? Applying straightforward MDA. Well, here with seed equals 0, we find that, oh, the standard deviation, the volatility of two-day backward-looking return is the most important feature. And the 5-day return is the second most important. Okay, you say, okay, well, that's interesting, you say. But wait a minute, let's try random seed equals 1. All of a sudden, the most important feature becomes the change in the volume. You say, what's going on? The volume predictor was, ranked 1, 2, 3, 4, 5, 6, 7, 7 in the first ranking, right? This is where it was originally. But when you rank it using a different random seed, all of a sudden it becomes the most important ranking. You say, what is this about? It's a big mess. And that is common for any feature selection. You can use Sharp, you can use Slime, you can use MDA, and they are all going to give you different ranking every time you run it with random seed. It's not just our observation, although it is not commonly discussed until our paper that was published in the Journal of Financial Data Science. It was not commonly discussed. I have talked to industry experts on this, and some of them know about it, others don't. But even those people who know about it are using very ad hoc methods to deal with it. And what we have described in our first paper is a systematic method to deal with it. But what we described in our second paper, called cluster-based feature selection, is a much more powerful way to deal with this. After we apply cluster-based feature selection, this kind of randomness in the ranking, this kind of non-reproducibility is finally solved.